In just 1 week, strictly between March 8th and March 14th, 2026, the window for a global cyber attack collapsed to a mere 48 hours.
Yeah. And a medical AI matched human doctors with zero safety stops.
Right. And meanwhile, Europe debated rewriting the foundational laws of the internet.
It was a massive week.
It really was. Welcome to this week's deep dive. We are keeping a very strict focus on Google AI updates published during the specific 7-day window.
And, the mission for our deep dive today is tracking a clear narrative shift in the data you're going to hear.
Exactly. This is the week we see Google's AI aggressively transitioning from simulated benchmarks in the laboratory directly into empirical real-world deployment.
Right. We're looking at a very clear operational pipeline here. It starts down at the foundational level, scaling up custom silicon to handle unprecedented compute loads.
And that compute allows massive multimodal models to just seamlessly integrate into global consumer products.
Exactly. And finally, there's this simultaneous super high-stakes race to secure these massive systems against new threats that are now operating at machine speed.
So let's start right at the foundation of that shift, which is the research lab. This is where models are finally tackling the chaos of the real physical world, starting with human health.
Which is arguably the most complex environment.
Absolutely. The headline here comes from the Google Research blog, published globally on March 11th. Google Research and DeepMind released a landmark clinical study on AAE.
Right, ADE. That's their conversational diagnostic AI.
Yes. And the methodology is what makes this a real breakthrough.
Oh, for sure. Because for years, medical AI was tested on static multiple choice medical board exams. It was very theoretical.
Right, like textbook learning?
Exactly. But this was a pre-registered IRB-approved clinical study. They put it in a live ambulatory clinic with 100 adult patients.
Real people.
Real people seeking treatment for new, non-emergency episodic complaints. They interacted with AMIE via a text-based chat interface to complete a pre-visit clinical history before they even saw their actual doctor.
And the performance metrics are just staggering. The AI matched human primary care providers in differential diagnosis accuracy.
Wow.
Yeah, it included the correct final diagnosis in its top 7 possibilities 90% of the time.
That's incredible.
But here is the critical data point for you. Human clinicians supervised this entire process via screen share.
Okay.
And they were explicitly trained to hit an emergency stop button if the AI gave dangerous advice or, missed signs of severe distress.
Let me guess.
They had to use that stop button 0 times.
0 safety stops in an unsimulated, highly regulated medical environment.
Yeah.
That proves the fundamental architecture is viable. AI is essentially moving from textbook learning into its residency.
That's a great way to put it.
It's navigating the ambiguity of a patient who might not even know how to describe their own symptoms accurately.
Right. But I have to play devil's advocate for you on this one.
Go for it.
100 patients is a fantastic proof of concept for a research paper. But realistically, is a sample size of 100 enough to prove empirical safety for a global medical rollout?
Oh, it absolutely is not. And to be fair, the researchers explicitly acknowledge those limitations in the paper.
Right. They aren't hiding it.
No, not at all.
Yeah.
For instance, the interface was text only. That means the AI completely misses auditory cues, like a patient wheezing.
Or visual cues, like a skin rash.
Exactly. The significance of this study isn't that AI is ready to replace doctors tomorrow. It's about proving the feasibility of a human-in-the-loop architecture.
Meaning the AI handles the paperwork, essentially.
Right. It demonstrates that an AI can handle the rote initial data gathering phase safely, which then shifts the physician's role to high-value data verification and, empathetic shared decision-making.
Well, if the AI can parse the messy, unstructured data of a human patient's symptoms, it makes sense they would point that exact same reasoning engine at planetary data.
Oh, absolutely.
Which leads to our second research headline, also from the Google Research blog. They introduced a methodology called Groundsource.
Right, utilizing the Gemini model.
Yes, to extract 2.6 million historical flood records from 5 million unstructured global news reports.
And this directly addresses a massive infrastructure problem in the Global South. It's known as the data desert.
Explain that for a second.
Sure. So for slow-moving river floods, you can just install physical stream gauges. It's relatively easy to track.
Right.
But urban flash floods happen incredibly fast, mostly driven by intense rainfall and concrete infrastructure. In many vulnerable regions, the historical ground truth data required to train a predictive AI model simply did not exist.
There were no sensors.
Exactly. No sensors, no data.
So Groundsource basically acts as a tireless digital archivist. I mean, it speed-read 2 decades of local newspapers, municipal reports, and civil defense bulletins across 80 different languages.
Which is a scale humans just can't match.
Right, and it found patterns that humans completely missed. It used a specific 3-step prompt protocol.
Okay, what were the steps?
First, classification. To ensure the article was about a physical flood and not like a metaphorical flood of complaints.
Oh, that's smart. Language is tricky.
Very. Then, temporal reasoning to pin down the exact date. And finally, spatial precision to map it to a specific neighborhood.
And the metric that matters here for you is parity. Because of this synthetically structured historical data, Google's neural networks can now forecast urban flash floods up to 24 hours in advance.
Wow.
Yeah, and they operate at a 20 by 20 kilometer spatial resolution. They've effectively closed the forecasting gap between wealthy, highly monitored developed nations and the global south.
Now, with models demonstrating deep medical empathy on one hand and predicting natural disasters on the other, it's really easy for humans to project a sense of humanity onto the software.
Oh, it happens all the time.
Which makes our third research headline critical context. Google DeepMind published a theoretical paper titled The Abstraction Fallacy: Why AI Can Simulate but Not Instantiate Consciousness.
This is such a vital paper. As Google scales these foundational models toward artificial general intelligence, or AGI, defining what the model actually is becomes a crucial scientific framework.
And an ethical one.
Definitely. The DeepMind paper argues that advanced large language models merely simulate consciousness through complex mathematical abstraction.
So give me a concrete way to think about that abstraction fallacy. What is the practical difference between simulating and instantiating consciousness in a tool like AIU?
Think of it as the difference between a weather simulation and actual rain.
Okay.
A weather simulation running on a supercomputer can perfectly model a hurricane. It tracks the wind, the pressure, the moisture, but the computer itself doesn't get wet.
Oh, that makes sense.
Right. So when a medical AI generates a deeply sympathetic response to a patient in distress, it is statistically predicting the most empathetic sequence of words based on billions of human interactions.
So it's just predicting tokens.
Exactly. It is not feeling empathy. Understanding that distinction is vital for assigning medical and legal liability as these systems deploy globally.
It grounds the conversation in mathematics rather than, anthropomorphic science fiction.
Precisely.
Taking that mathematical ability to parse messy, real-world data out of the research lab, Google is fundamentally altering how you interact with physical and digital spaces. Let's look at the product side.
This is where things get really visible to the average user.
Right. Starting with a headline from the keyword, Google's official blog, Google Maps globally launched Ask Maps and immersive navigation.
This is a prime example of the Gemini model being deeply embedded into a global consumer product. Ask Maps processes multivariable conversational queries across 300 million map locations.
And 500 million community reviews. But I look at this and I have to ask, how is asking Gemini for a quiet coffee shop with fast Wi-Fi any different from the keyword filters we've used on map applications for a decade? We already have buttons for open now or top rated.
It's a fair question. The difference is semantic intent versus rigid tagging. Historically, a business only showed up in a search if the owner manually checked a box for Wi-Fi.
Right.
Or if a user explicitly typed the exact keyword quiet in a review. But Gemini isn't looking for exact word matches. It reads through those 500 million unstructured community reviews to understand the actual vibe and context of a place.
So it's reading between the lines.
Exactly. It knows the review saying, "Great place to read a book without being bothered," implies it is quiet, even if the word quiet is never explicitly used.
That forces a massive paradigm shift in how brick-and-mortar businesses optimize for visibility. You can't just stuff keywords into your profile anymore.
No, you have to actually provide the experience people are talking about.
And immersive navigation pairs with this intent-based search. It provides a 3D driving view highlighting specific lanes and crosswalks.
Which is visually stunning.
It is. But underneath that interface, it's processing 5 million traffic updates per second to calculate predictive route trade-offs.
5 million a second.
Yeah. It's actively comparing a longer traffic-free route against a faster toll road using real-time spatial intelligence.
To process that level of semantic intent, you need a highly capable underlying model, which ties perfectly into the Google Workspace updates rolled out for Google AI Ultra and Pro subscribers.
Right. This was also announced on the keyword. We're seeing the integration of the new Gemini 3.1 Pro model into daily workflows.
And what did they add specifically?
They launched source-aware drafting in Docs, an Ask Gemini tool in Drive, and automated spreadsheet building in Sheets, which, by the way, is reportedly 9 times faster than manual entry.
It essentially turns Google Workspace from a passive digital filing cabinet into an active synthetic employee.
That's a great analogy.
Yeah, it's no longer just checking your spelling. It's an intelligent agent capable of synthesizing your emails, your financial documents, and your meeting notes to generate actionable, multivariable outputs.
Now, for the developers who are actually building the next wave of these enterprise applications, Google released something massive on the Gemini API platform, the Gemini Embedding 2 preview.
This represents a huge structural breakthrough in foundational model architecture. It is their first natively multimodal embedding model.
So what does that actually mean for a developer?
Well, historically, if a developer wanted an AI to search a database that contained both text documents and images, they had to use different models.
Okay.
And they had to run them through complex, high-latency translation layers to compare the different data types. It was slow and expensive.
I think of Gemini Embedding 2 as a universal blender for data.
I like that.
If you're building an app, you no longer have to build 3 different search tools. You can take a textbook, a DVD, and an audio cassette tape, throw them all into this digital blender, and get a single searchable flavor. It simultaneously maps text, images, video, audio, and documents into a single unified vector space.
And for anyone managing a corporate database, the efficiency gains here are just staggering. Specifically for enterprise array pipelines.
RA meaning retrieval augmented generation.
Right. It's how a company lets an AI securely search its own internal data. By eliminating the intermediary translation layers, developers can build applications that instantly understand the context of a video meeting recording just as easily as a text-based PDF.
But to process 5 million traffic updates a second on maps, and to run multimodal vector math natively without translation layers, you need incomprehensible amounts of compute power.
You really do. Hardware is the bottleneck.
Which leads us directly to this week's infrastructure escalation. Industry reports and internal memos revealed Google's newest custom AI accelerator TPU, called Ironwood.
Ironwood represents a profound competitive moat. The silicon is capable of achieving up to 4,614 TFLOPs of peak performance using an FP8 precision benchmark.
That is a lot of numbers.
It is. And they aren't deploying a handful of these. They are racking them in massive configurations of up to 9,216 liquid-cooled chips.
Let's contextualize that FP8 precision benchmark for a second. What does that actually mean for the performance of the chip?
So FP8 stands for 8-bit floating point format. When training neural networks, you don't always need microscopic mathematical precision. You need extreme speed and volume.
Right.
FP8 allows the chip to calculate at blistering speeds without using up the massive amounts of memory required for higher precision math. It is a deliberate trade-off that maximizes the sheer volume of data the chip can chew through per second.
Now, an internal memo indicated that Google's mandate is to double compute capacity every 6 months, just to keep up with internal and external demand.
That's the pace of the arms race right now.
But if the mandate is to double compute capacity twice a year, at what point do the laws of physics or just the global power grid say stop? How is this sustainable?
That is the defining infrastructure question of the decade. And the answer lies entirely in vertical integration.
Meaning controlling the whole pipeline?
Exactly. By designing the custom Ironwood silicon themselves, building their own liquid-cooled data centers, and coding the Gemini models that run on them, Google is optimizing every single layer of the stack.
Right, there's no wasted efficiency.
Vertical integration is the only way to keep financial costs down and energy efficiency up while competing at this scale. They are ruthlessly eliminating their reliance on third-party vendors for critical bottlenecks.
So Ironwood is the engine making the ecosystem possible. But the sheer computing power of Ironwood doesn't just empower Google's developers. It empowers threat actors, too.
Unfortunately, yes.
The threat landscape is accelerating at the exact same machine speed, which brings us to our safety, policy, and security segment. The Google Cloud Office of the CISO released the Cloud Threat Horizons report globally.
And the data in this report requires a total rethink of enterprise security. It revealed that vulnerability exploitation windows have collapsed from weeks to mere days.
It's terrifying.
Threat actors are now deploying malicious payloads in as little as 48 hours post-disclosure.
48 hours. And the report highlights a massive tactical pivot. The exploitation of third-party software vulnerabilities now accounts for 44.5% of incidents.
Which completely eclipses traditional credential theft like phishing.
Right. Why is this happening so fast now?
This shift is driven entirely by AI-assisted attack tools. Hackers are using automated systems to scan the entire internet for a newly disclosed vulnerability and deploy exploits at an industrial scale.
So they don't even have to look for you manually.
No, a human analyst simply cannot patch a system across a global enterprise faster than an AI script can exploit it in 48 hours. Reactive, human-led security is dead.
Defenders now need AI to fight AI, which perfectly explains the timing of our next headline from the Google Cloud Press Corner. Google formally completed its multi-billion-dollar acquisition of the cloud and AI security platform Wiz.
Right. Integrating Wiz's code-to-cloud context directly into Google's infrastructure provides enterprises with the automated, machine-speed defenses they require.
It gives defenders the autonomous AI tools necessary to secure multi-cloud environments against autonomous AI threats.
It's literally machines fighting machines at this point.
And while Google is battling threat actors in the cloud, they are also battling regulators in the courts. And this next story could reshape the entire global architecture of artificial intelligence.
This was a huge deal in Europe.
It was. The Court of Justice of the European Union held a historic 6-hour hearing in, Company v. Google Ireland Limited.
A Hungarian media firm brought the case, alleging that Google's Gemini model extracted and processed their protected journalistic content during its training phase without authorization.
Right. The court is trying to determine if training large language models on copyrighted material falls under the text and data mining, or TDM, exception in European law.
Yes.
But I need some technical clarification on this because the court was debating highly specific mechanisms. Several EU member states are pushing something called a unitary process theory. What does that mean, and how does it relate to the mathematical process of next token prediction?
Okay, so Google's defense is rooted in the technical reality of how a neural network learns. The model uses next token prediction, which is a probabilistic mathematical process.
Okay.
It studies billions of texts to learn the statistical probability of which word should come next in a sentence.
Yeah.
It isn't copying and pasting a copyrighted article. It is doing math on it to learn the underlying patterns of human language.
So Google is arguing that calculating the statistical weight of a word is not the same thing as reproducing or publishing a copyrighted work.
Exactly. But the unitary process theory being pushed in the EU argues that if an AI system is accessible to users within the European Union, strict European copyright frameworks should govern its entire lifecycle.
Meaning what, practically?
They are arguing that the initial scraping, the mathematical training, and the final output are all one single unitary act of communication to the public.
Wait, if the court rules that doing math on a copyrighted word is the same thing as publishing it, doesn't that make the foundational training of any neural network legally impossible within the borders of the EU?
It absolutely threatens the fundamental architecture.
Mm.
If the court adopts the unitary process theory and rejects the TDM exception, it could restrict data scraping globally just to comply with EU market access.
Wow.
This is the ultimate clash between cutting-edge mathematical reality and legacy copyright law.
Yet, despite the regulatory hurdles in Europe and the 48-hour security challenges we talked about, enterprise adoption of these multimodal capabilities is still scaling incredibly fast.
Oh, businesses aren't slowing down.
Not at all. It is putting Hollywood-grade tools directly into the hands of global businesses. Let's look at enterprise partnerships to close things out. From the Google Cloud Press Corner, Google Cloud announced a strategic partnership with Brahma AI.
Brahma AI and Google are collaborating to scale multilingual, high-fidelity digital humans for enterprise use cases.
Digital humans.
Yeah, primarily targeting healthcare and retail customer service.
This basically gives every business Hollywood-grade CGI on demand, but driven by a brain instead of an animator.
That's a great way to think about it.
By utilizing Google's VO for video generation, Gemini for reasoning, and Google text-to-speech, businesses can deploy interactive, movie-quality digital avatars. And crucially, these come with built-in consent governance and digital watermarking to prevent deepfake abuse.
Which is so important right now. And, we saw another major media application of this generative stack announced in Europe.
Right. Canonal Plus Array.
Yes, the French media giant Canal Plus partnered with Google Cloud to integrate VO3 and the generative AI stack into their production workflows.
They are using it to index their massive video library and provide AI-assisted content creation tools to their production partners.
And if you connect the CanL Plus deal back to the Gemini Embedding 2 breakthrough we discussed earlier, it perfectly illustrates the paradigm shift.
How so?
They are searching a legacy video library using multimodal AI. A producer can search for a highly specific scene based on the visual context or the audio dialogue without relying on humans to manually type out metadata tags for every single frame of footage.
Right, the blender analogy.
Exactly. AI-native video indexing has officially transitioned from an experimental novelty to a table stakes workflow in mainstream media production.
So, what does this all mean for you? Let's take a step back and look at the massive scope of what happened in just 1 week at Google. We went from the raw, liquid-cooled silicon of the Ironwood chips and the integration of the Gemini 3.1 Pro models all the way down to real-world impact.
From the hardware to the human level.
Yes. We are predicting urban flash floods in the global south, matching human doctors in primary care clinics, and powering digital humans for enterprise retail.
It is a profound shift from theory to operational reality. The infrastructure is scaling vertically to meet demand, the security parameters are transitioning to autonomous machine speed defenses, and the models are fundamentally altering how we search and interact with our physical cities and digital documents.
It really forces you to examine the relationship we are building with this technology. Which brings us to a final thought for you to mull over.
Let's hear it.
With tools like Groundsource, tirelessly reading millions of unstructured news articles to predict floods, and Ask Maps analyzing 500 million human reviews to understand the nuances of a neighborhood, are we building AI to better understand the chaotic, messy human world? Or are we slowly formatting the human world strictly so that an AI can read it?
That is the defining question of this era.
Thank you for joining us for this week's deep dive into the source material. We'll be back next time to unpack the next wave of developments. Until then, keep questioning the data.